a current of 6 amperes was passed through 6 amperes was passed through aluminium chloride solution. Aluminium chloride solution for 15 minutes. For 15 minutes using platinum electrode. Using platinum electrode. Okay. When 0.504 gram of aluminium is produced. So now the question that they are asking is, what is the molar mass? What is molar mass of aluminium? See, the formula is W, the weight of this aluminium, will be equal to mole ratio into molar mass into I into T upon 96,500. Okay. So what we have is mole ratio is, see, if I write the reduction reaction, aluminium plus 3 electron forms aluminium. So I'll repeat once again. See, this is ion, this is moles of electron, and this is moles of substance. So mole ratio will be mole of substance 1 upon mole of electron 3, 1 by 3. Okay. So we have the other values. Weight of substance was 0.504, that is equal to 1 by 3 into molar mass into I. The current was 6 into 15 into 60. I told you 15 minutes, we got it in seconds because ampere second is coulomb. Divide by 96,500 coulomb. So what do we have? 0.504 into 96,500 into 3 upon 6 into 15 into 60 will be m, the molar mass. So how much will it be? So we have 0.504 into 96,500 into 3 divided by 6 divided by 15 divided by 60. So absolutely right, now because we know the molar mass is 27 gram per mole. So just don't write 27, write the units. 27 gram per mole is the molar mass. Okay, you can have a look at it. If you're copying it, it's good. Then we come to the eighth sum. How many moles of this question is more related to the entrance exam point. We'll do from that point of view. How many moles of electrons are required? How many moles of electrons are required? How many moles of electrons are required for the reduction of A, 3 moles of zinc plus 2 to zinc, B, 1 mole of chromium plus 3 to chromium. See, we need this more for the entrance exam actually, shortcut ke liye. So first what you write is, you write the actual equation. A, zinc plus 2 electron forms zinc, What does this mean? It means that 1 mole of zinc ion requires 2 moles of electron to form 1 mole of zinc metal. Now they have said if you take 3 moles of zinc ion, so this will become 3, this will become 6, and this will become 3. So what is the question? How many moles of electron? So it will be 6 moles of electrons. So the answer is 6 moles of electrons, or if they ask in terms of coulomb, what it will be 6 into 96,500 coulomb. Then we come to the B part. 1 mole of chromium, that's an easy one. So write the equation Cr plus 3 electrons form Cr. So for 1 mole of chromium, 3 moles of electrons are required. So the answer is 3 moles of electron. It is clear. If they ask 3 moles of electron in terms of charge coulomb, that is 3 into 96,500 coulomb. So this takes care of the 8th sum. Okay. Then we come to what? Okay. Then we talk about the 9th sum. In the electrolysis of AgNO3, in the electrolysis of silver nitrate AgNO3 solution, 0.7 grams of silver I'll write it once again. In the electrolysis of silver nitrate solution, 0.7 grams of silver is deposited after a certain period of time. After a certain period of time. Calculate the quantity of electricity. Calculate the quantity of electricity required in coulombs molar mass of silver. Molar mass of silver is 107.9 gram per mole. Okay. So, what do we have? Weight of substance deposited is mole ratio into molar mass into I into T upon 96,500. This I into T is the coulomb. Calculate the required in coulombs when they say this is what is coulomb. So W into 96,500 upon mole ratio into molar mass is I into T, that is generally Q. Generally we write as Q. This is clear. So W, the weight deposited, will be 0.7 into 96,500. Now mole ratio, I told you, you have to write the reduction reaction. What is this thing we have got? Silver. So mole ratio is 1. Why? Ag plus an electron forms Ag. So this is ion, this is electron, and this is substance. So mole ratio will be mole of substance 1 upon 1. So this is 1 into molar mass is 107.9. So how much does it work out to? 0.7 into 96,500 divided by 107.9. So that will be equal to 626 coulombs. So that will be equal to 626 coulomb. Coulomb is capital C. Is this point clear? So now we will come to what? The 10th sum. Calculate the amount of sodium, calculate the amount of sodium and chlorine gas produced during the electrolysis of fused sodium chloride by the passage of by the passage of 1 ampere current for 25 minutes. 1 ampere current for 25 minutes. Molar mass of sodium and chlorine are. Molar mass of sodium and chlorine are 23 and 71. 23 gram per mole and 71 gram per mole. Okay. So what we have to find out? Amount of sodium and chlorine produced. So we can even do one thing. We'll go one step further. Volume. I'll teach you that also. We'll take this opportunity. First I'll find out the amount of chlorine produced and then volume how we will calculate. So we have weight of sodium. Now first write down the reduction reaction. Na plus an electron forms Na. So your mole ratio is 1 upon 1 because this is substance and this is electron. So mole ratio will be equal to 1. So weight of substance will be mole ratio into molar mass into I into T upon 96,500. Okay. So what do we have? Weight is what they have asked, weight of sodium. So mole ratio 1, molar mass is 23. I, the current, if I remember, was 1 ampere into 25 into 60 divided by 96,500 coulomb. So how much does it come to? 23 into 25 into 60 divided by 96,500. So that is 0.357. So this is 0.3575 grams. In the second part of the story now, I am not trying to find out as they are saying weight. That's easy to find, again same logic. But what if they turn the question and ask what is the volume of chlorine evolved? So only one change that you have to do. What is it? So let's write. So we have, see, chlorine, Cl2 plus 2 electrons forms 2 Cl minus. Reduction reaction. Huh? So here this is substance, this is moles of electron, and this is ions. So your mole ratio will be 1/2. Mole of substance upon mole of electron. Okay. Now instead of, we'll change that to our convenience. We'll say what is the volume of chlorine evolved. Only one change you have to do. Volume of chlorine gas evolved will be, the story will remain the same, mole ratio, but here instead of molar mass, you have the molar volume. You have molar volume into I into T upon 96,500. What is molar volume? 22,400 ml. 1 mole of any gas has a volume of 22,400 ml at STP. That's what you have to substitute. So now we get volume of chlorine gas will be 1/2 into 22,400 into 1 into 25 into 60 upon 96,500. So how much? This will be volume in ml. Huh? This will be volume in ml. So how much will this come to? 22,400 into 0.5 into 25 into 60 divided by 96,500. So that will be 174. So volume of chlorine gas will be 174 ml at STP. So nowadays if you see, more questions are being asked on volume evolved. That's why I am teaching you this. Okay. Calculate the mass of magnesium and volume of chlorine produced, volume of chlorine gas at STP, volume of chlorine gas at STP produced during the electrolysis of molten magnesium chloride. Molten magnesium chloride by passage of by passage of 2 ampere current, okay, for 1 hour. For 1 hour, molar masses of magnesium 24 gram per mole and chlorine is 71. We don't require chlorine ka 71. Okay, chalo, let's start. So the first part, write down the reduction reaction of magnesium. So Mg plus 2 electron forms Mg. So this is ion, this is moles of electron, and this is substance. Correct? So your mole ratio Mr will be 1/2 mole of substance upon mole of electron. Is this clear? Then they expected the board this way only, I am telling you. Mole ratio, they give half a mark for this, and the arrangement for this. Means there is a, not arrangement, there is a marking scheme for this. If you write this, then you write the formula. So weight of magnesium will be mole ratio into molar mass into I into T upon 96,500. So your weight of magnesium will be, mole ratio is 0.5, 1/2 is 0.5, into molar mass is 24, into I, the current was how much? 2 amperes. 1 hour is 3600 seconds, 60 minutes. 60 minutes is 60 into 60, 3600 seconds into divided by 96,500 coulomb. That's the only place where people make a mistake. They just take it as 1 hour, put 1 and finish it off. So 0.5 into 24 into 2 into 3600 divided by 96,500. So that is 0.895. So weight of magnesium was equal to 0.895 grams. 0.895 grams. Now we come to volume. So volume of chlorine will be mole ratio. So mole ratio is what? Reduction reaction. Cl2 plus 2 electron forms Cl minus. So your mole ratio will be equal to 1/2 because this is substance, this is electron, and this is ion. Mole of substance upon mole of electron, even though they are on the same side, doesn't matter. Is this clear? That's why every time I'm explaining, because this is where students get into trouble actually. So what do we have? So volume of chlorine will be mole ratio into molar volume into I into T upon 96,500. So volume of chlorine, mole ratio is 0.5, half, into 22,400 ml into I, the current was 2, into 3,600 divided by 96,500. So how much ml will this be? So 11,200 into 2, 2 into 0.5 is 1. So 22,400 into 3,600 divided by 96,500. So this is 835 ml. So volume of chlorine is 835.6 ml. Don't forget to write at STP. At STP. Is this clear? Okay. Now we look 11th sum, correct? 12th. In a certain electrolysis experiment, in a certain electrolysis experiment 0.561 gram of zinc is deposited. In one cell. In one cell containing zinc sulfate solution. Containing zinc sulfate solution. Calculate the mass of copper deposited in another cell connected in series with zinc sulfate cell. What have they given? Molar mass of zinc and copper are 65.4 and 63.5 gram per mole respectively. So what do we have? We find the mole ratio of zinc. Mole ratio of zinc first. So what do we have? Zinc plus 2 electron forms zinc. Then we find the mole ratio of copper. That is copper plus 2 electron forms copper. So here the mole ratio is 0.5, 1/2. Here also the mole ratio is 0.5. Remember, molar mass into mole ratio is equivalent weight. Something as simple as that also has been asked. So mole ratio into molar mass is equivalent weight. Is this clear? So we have to find out weight of copper. Weight of copper upon weight of zinc will be mole ratio of copper into molar mass of copper. Molar mass of copper upon mole ratio of zinc into molar mass of zinc. See, the mole ratio is the same for both. So weight of copper will be, weight of zinc was how much? 0.561 into molar mass of copper, that was 63.5, divided by that of zinc, correct, 63.5 and divided by 65.4. Your answer is true. So what do we have? Weight of copper 0.561 into 63.5 divided by 65.4. So that is 0.544. So weight of copper will be 0.544 grams. That is the answer. 13th sum. Two electrolytic cells one containing aluminium chloride solution and the other containing zinc sulphate solution. Are connected in series. Are connected in series. Okay, are connected in series. The same quantity of electricity is passed between the cells. Is passed between the cells. So what happens? Calculate the amount of zinc deposited if 1.2 grams of aluminium are deposited in aluminium chloride. In aluminium chloride cell. Molar mass of aluminium and zinc is 27 gram per mole and 65.4 gram per mole respectively. So let us start now. First we find the mole ratio for aluminium. So aluminium plus 3 electron forms aluminium. Then we have mole ratio for zinc. So zinc plus 2 electron forms zinc. So this is 1 by 3 and this is 1 by 2, that is 0.5. So what do we want to find out? Calculate what? Calculate the amount of zinc deposited. So weight of zinc upon weight of aluminium will be, what will this be? 1 by 2, that is 0.5 into molar mass of zinc is how much? 65.4 divided by 1 by 3 is 0.33 into 27. So weight of zinc will be equal to what? Into weight of aluminium. Weight of aluminium is how much? 1.2. That's it, your answer is true. So what do we have? 0.5 into 65.4 into 1.2 divided by 0.33 divided by 27. So 4.4. So weight of zinc deposited will be 4.4 grams. Don't write GM or GMS. Gram is simple G. It's clear. Some of these things are not taught actually. So the reaction. So 14th sum. Write the cell reaction. Okay, and calculate the EMF of the cell. And calculate the EMF of the cell. So what do we have? The PB plus 2 1 molar. Then you have Hg. This is calum electrode. Hg2Cl2 and you have KCl, saturated. Okay, so what is the cell reaction? This is anode and this is cathode. So at the anode, what we are expecting is oxidation. Now if you don't understand whether Pb to Pb plus 2 is oxidation or Pb plus 2 to Pb is oxidation, remember in 11th I had taught you number line method. We'll revise that today. Okay. So we have 0, 1, 2, 3, 4, minus 1, minus 2, minus 3. So when the change in oxidation is on the right hand side, that represents oxidation. So in this case, this is anode, we need the oxidation reaction. So lead is 0 to 0 plus 2 is oxidation and plus 2 to 0 is reduction. So since we are looking for oxidation, the reaction will be Pb plus 2, Pb forms Pb plus 2 electrons. Cathode is reduction. So you have Hg to Hg plus 1 or Hg plus 1 to Hg. So reduction is Hg2Cl2 plus 2 electron forms 2Hg. So your net cell reaction will be what? The net cell reaction will be, your net cell reaction will be Pb plus Hg2Cl2, these two get cancelled, forms Pb plus 2Hg plus 2Cl minus. The second thing that they have asked is, what is the EMF of the cell? So standard EMF of the cell is E0 of cathode, both reduction potential, minus E0 of anode. So let us see what they have given. E0 of cathode, they have given as 0.242 minus of minus 0.126. So that becomes 0.242 plus 0.126, 863. So your answer is 0.368 volt. That is the standard EMF of the cell. That is the standard EMF of the cell. Write the cell reaction write the cell reaction and calculate the standard potential of the cell and the standard potential of cell. What is given? Nickel plus 2, 1 molar. Then you have platinum, chlorine gas, 1 atmosphere, chloride ion, 1 molar. So everything is standard. It is clear. So cell reaction first. This is anode, this is cathode as per the convention. So at the anode, we are expecting oxidation reaction. So now nickel to nickel plus 2 or nickel plus 2 to nickel, which is oxidation? This is easy, but in difficult you have to use this. So nickel to nickel plus 2 is oxidation, nickel plus 2 to nickel is reduction. So we need the oxidation reaction. So nickel to nickel plus 2 electrons. Then we have cathode. The reaction is a reduction reaction. So now chlorine to chloride and chloride to chlorine, which will be reduction? Chlorine to chloride, because chloride to chlorine will be still going on the right hand side only. So reduction will be chlorine plus 2 electron forms 2 Cl minus. So your net cell reaction becomes nickel plus Cl2 forms nickel plus 2 Cl minus. Now what do we have? We have E naught of the cell will be E naught of cathode minus E naught of anode. So your cathode is chlorine. So they have given this is chlorine will be E naught of chlorine will be plus 1.36 and E naught of nickel will be minus 0.25. So what will happen then? So E naught of cell will be E naught of chlorine minus E naught of nickel, cathode minus anode. So this will be 1.36 minus of minus 0.25. So this will be 1, then 36. So 1.61 volt. 1.61 volt. Yeah, we have time. We can push a little more. Sum. Consider quite a big sum. Consider the following cell. Consider the following cell. We have Pb solid, Pb plus 2, 0.5 molar, copper plus 2, 0.001 molar, and then copper. Okay, write the cell reaction. See, anode, what do we have? Anode will be Pb forms Pb plus 2 electron oxidation. I told you, lead to lead plus 2 is oxidation, lead plus 2 to lead is reduction. Then we have cathode reduction. So here we'll have copper plus 2 electron forms copper. So net cell reaction is Pb plus Cu plus 2 forms Pb plus 2 plus Cu. Okay. Now we'll find the E0 of the cell first. E naught of this cell will be equal to what? 126. So copper was, so this is 0.334 minus of minus 0. How much? 126. So that is 6 plus 4, 10, 1 here, 3 and 3, 6. So 0.460 volt. Now according to Nernst equation, E of the cell will be E naught of the cell minus 0.0591 upon N. Okay. Log to the base 10 of concentration of product upon the concentration of reactant. So E of the cell will be 0.46 minus 0.0591 upon N was 2, because in both the cases the electron change was 2. Is this clear? N log to the base 10 of, what was the product concentration? Lead The lead concentration was 0.5 upon what do we have? Concentration of copper, that is 10 raised to minus 3. So therefore E of the cell will be 0.46 minus 0.0591 upon 2 log to the base 10 of, see, 0.5 is 5 into 10 raised to minus 1 into 10 raised to plus 3. So this becomes 500. Log of 500 is 1.6990. So E of the cell is, I know this by heart. So 0.46 minus 0.0591 upon 2 into 1.6990. So what is the value you get? Point 0.0591 into 1.6990 divided by 2. So that is 0.05. So E of the cell will be 0.46 minus 0.05. 46. So this will be E of the cell will be 0.41 volt. This is spontaneous redox reaction. Why?